Hello and welcome to part 3 of the video series 3D interactive visualizations. In the previous part 2, we saw how to plot three-dimensional decision surfaces for classification data. And that visualization was not only about decision surfaces. Actually, we show there that you can plot any kind of surface as long as you have three features or three variables. And the important part was to make a grid of two of the variables, maybe x and y, and find out the third variables that satisfy the whatever the model equation do you have, and finding out root of that model. We use MP-Math library for that. In this particular part, we are going to look onto multiple surfaces, and sometimes it becomes important that we need to investigate the underlying surface or underlying function that the model comprises, or the distribution that the data has. And we sometimes do not have access to all the surface. We have access to some data, possibly with noise. So how can we actually see how this sampling can be made, and how these surfaces and all these kind of samplings, and if we have to sample a few points with noise, what is the relationship of the actual surface plot with these kind of scatter plots with a few data points or maybe large data points? And what if we want to mix scatter plots, the plots with scatter points, and the surfaces together into single plots? So in this particular video, we are going to talk about that, and again we'll be focusing on plotly graph objects for that. So let's dive in. As you again import certain packages that you need, numpy as np, and import plotly dot graph objs as go. So let's import them and hope everything is fine. Next, we make this grid. So let's say xy is np.mesh grid, and maybe we make that a grid, for example, np.lin space, start from, for example, -2, go to 2, and make, for example, or maybe from -3 to 3, and make for sample, for example, 40 points. And then we have np.lin space, another one. So go from, again, for example, from -3 and 3. You need not to keep these starting at any point same, but what you need to keep is the number of points that should be same. So let's say, by the way, even if the number of points are not same, the grid will be rectangular, and that's okay as well. So let's have this grid. So x.shape, if you see x.shape, that is this. Y.shape, that is this. So 40 by 40 grid. Now what we do is, let's define some surface, the original surface, let's say without any kind of noise or any kind of sampling and stuff. np.cos, let's say x square plus, let's say y square. Let's say that's our capital Z. Let's say that's our surface, which has this particular relationship with x and y. So after defining that, let's plot that surface. Fig is equal to go dot figure, and we have, let's say, data equals to this, and we can have here, for example, go dot surface. We want a surface plot. Small x is equal to x, small y is equal to y, and small z is equal to capital Z. Let's say that's our plot, and now we say, okay, fig dot show. That's our surface here. So now you can see here, this is the surface. Yeah, that's cool, very cool. We can just change its size and see what this surface is. That's the surface. Yeah. So that's the surface. Let's say we want to sample some points. Let's say every fifth point. let's say we want to sample every fifth point of that and want to make a scatter plot on top of this, and assume that those are the sample points that are available to estimate this surface. So let's see. Let's sample some points. So let's say we have go dot scatter 3D x is equal to x dot flatten, and we sample, let's say, every fifth point. Let's say we sample every fifth point. Then y is equal to y dot flatten, and we again, let's say, sample every fifth point. And then we have, let's say, small z is z dot flatten, and we sample again every fifth point from that. Let's set some other parameters like opacity, opacity, opacity. Let's say opacity is 0.7 maybe, and let's set the scatter plot mode as markers. So so what will happen now with this command, what will happen is some of the points, they will be highlighted on the surface as well as the surface. So let's see. Oh, there's a problem. What's the problem? Invalid syntax. Go dot scatter 3D. What's the invalid syntax here? X dot flatten. What's the problem? Capital X dot flatten this. Go dot scatter 3D. Are the spelling correct? Oh, we have to write a comma there because we are making multiple plots. So that's the first plot and that's the second plot. Yeah, so we have to separate them by comma. Yeah, that's the problem. Oh, I guess this problem stays there because of this. Oh, what's the problem now? Oh, here we have to write this 0.7 rather than this. So now let's see. As you can see here, let me just yeah. So as you can see, there are some points that are being highlighted on this surface. I can make the opacity high just to view these points more concretely. So yeah, so these are the points. Let's say if we just sample these points on the surface and we want to estimate the underlying surface, what will happen? What happen normally in machine learning problems, what happen normally is this original surface is not available. All we have is this data, that is the sample data. All we have is this data. And our goal is really to find out the underlying function that actually govern this data. And what further happens is this data normally is not available in a huge quantity. The data is small, and sometimes finding out the underlying surface is not that simple. So for example, if we sample every 10th point, then you can see the data may not reflect a good pattern. But if you, for example, if you see that you may get or may not get what is the underlying function, you may come up with multiple functions that, multiple surfaces that this data lie onto. And so what happens is this, what we really want by our machine learning model is to estimate the underlying function. So our goal is, given very small amount of data, we really want to find out the underlying pattern that is there in the data. But the problem is, what really happens is that this data sometimes, the data that is given to us is sometimes noisy. So the data may not be very, for example, the data may not be that exact. It may have certain noises in there. So for example, if we just say, okay, z2 is equal to z dot dot copy, for example, and z2 is equal to np.z2 is equal to z2 plus np.random.rand. So if we add a random noise there, for example, 40 by 40, that random noise. So, and then this z2 is defined, then what happens is the data we find here, so if we deploy here z2, then the data we find really is noisy, and we need to estimate our surface in the presence of noise. So sometimes what happens is the data given to us does not exactly reflect what is happening, although it has a lot of pattern, but it has noise as well. So for example, if I just give you some amount of data, just a few amount of data, and I do not give you the actual surface. For example, in this particular case, if I just hide the surface and I give you this data which has noise as well, then it might be very hard in the presence of noise to really find out the underlying surface, and in turn, if the quantity of the data is reduced further, which normally is happen, the data is not available in really a bulk of quantity, then and in the noise and in the presence of noise, it is really hard to estimate what is the surface. And that's a typical problem in machine learning, where all the machine learning that deals with if you have a small amount of data and you do not know what is the actual pattern and you want to learn the pattern from the data, how can you go about that? Yeah. So that's the picture. That's a real picture that is happening. So before ending this, I just want to show you one more plot, not related to this, just to tell you how can you add multiple plots in there. We may have another plot, for example, Z3, for example, equals to, let's say, np.cos of x plus np.sin of y maybe. And let's have another scatter plot for this particular plot as well. So yeah, so let's see, we have another plot where we are going to make the opacity here as, let's say, 0.7, and here we are going to make the opacity as 0.7, and we have this, let's sample only 5 points, let's sample only 5 points, let's sample only 5 points, but now we're sampling from Z3 rather than Z2, and this plot will also be appear on top of the same plot. So one plot with one surface and two scatter plots. So let's see. No, why not? What's the problem? Invalid syntax. Again, I have done some mistake. Oh, I have missed this comma. I miss this always. That's bad. So now you can see a plot with, yeah, that's beautiful. So you can have a surface, its points are in red, and there is another data set that is in green that you have just plotted on top of that, maybe to find out the correlations among two different data sets or stuff like so. But at the end of the day, what I'm talking about is you can have multiple plots on multiple three-dimensional data plots onto a same single plot, and it is all interactive. Yeah. So that's about it. If you like our content here, do like our video, subscribe our channel, and share the video with your friends, and keep watching. So hope to see you next time.